Psychoacoustics and the physiology of hearing. Inside the ear we have a rather complicated structure which essentially is the cochlea, which is a shell-like construction. It's a spiral of fluid, and within that fluid we have nerve endings which are responding to the impulses which are transmitted from the eardrum. The eardrum, of course, is responding to the impulses which it is detecting from the sound which is picking up on the outside of the ear. These nerve endings are arranged throughout the length of the cochlea as it's coiled round, so that the ones which are towards the outermost edge of the cochlea, towards the outside of the ear as it were, those are the ones which are responding to the higher frequencies. The further that you go into the cochlea, into the central part of the cochlea, those nerve endings are responding to the lowest frequencies. So we have a whole sort of frequency range that we pick up depending on the positioning of the fibres within the ear. The fibres are actually different lengths and are vibrating in sympathy or in resonance with the sounds that they're picking up. Essentially, when the ear responds to a sound, if there are frequencies which are very close to each other, then they will be affecting the nerve endings in a very small and localised part of that cochlea. This is something that we can make use of in encoding and compression of sound, because we can say that if there are two sounds close together, then the ear will detect the louder of these two sounds and will apply lower priority in its response to the lower of those two signals. So essentially we can say that we have two signals. One is being to a certain extent rejected, and so we can apply less coding to that particular signal, and one is the prioritising sound, and we can devote more coding to that signal.